So this is the alpha oxidation. So alpha oxidation is mainly running for those fatty acids which are having a side chain on the beta position. So it cannot undergo normal beta oxidation because the beta carbon is blocked with the side chain, and the enzymes cannot come and act on the beta carbon atom to carry out the beta oxidation. So what happens? The carbon dioxide at the end, at the terminal, the first carbon atom is removed in the form of carbon dioxide, converting it into an odd chain, or suppose if it is a and very long chain fatty acid odd chain, suppose C23 angle, what happens? The first carbon dioxide goes and it will be converted to an even chain very long chain fatty acid. So it depends on the number of carbon atoms. So we cannot say that always a phytanic acid comes, but a typical example for an fatty acid which is undergoing alpha oxidation is a phytanic acid, which is C20 or even chain very long chain fatty acid. Clear? So the phytanic acid is a common example for a fatty acid which is undergoing alpha oxidation because it's having substituent groups on the beta position. So it cannot undergo the normal beta oxidation. So first what happens? The 20 carbon will be converted into a 19 carbon pristanic acid. Then this pristanic acid undergoes what? Usual beta oxidation. But since it's again a very long chain fatty acid, what happens? First the peroxomal oxidation happens, then it gets reduced to a short chain or a medium chain fatty acid, then it enters into the mitochondrial matrix and follows the complete oxidation, resulting in the formation of if it's a 19 carbon atom. So 17 plus 2, 19. So it's 16. 8 molecules of acetyl-CoA and 1 molecule of propionyl-CoA. So 16 plus 3, 19. Okay. So 8 molecules of acetyl-CoA and 1 molecule of propionyl-CoA will be formed. Clear? So that is a alpha chain oxidation. Now comes another minor pathway which is happening, which is known as omega oxidation. Omega oxidation is a type of oxidation where the oxidation is happening from the farthest end. Right? Oxidation from the side of the functional group. Carboxyl group carbonyl group alpha position, first position oxidation was initiated. Now omega oxidation is a type of oxidation in which the oxidation happens from the omega last carbon, that methyl group which is lying at the farthest end with respect to the carbonyl group. Anganeyulla oxidation we call this omega oxidation, and again it is happening in the microsomes. Microsomes it is happening. Microsomes are structures which are present on or bodies or the projections which are present on the rough endoplasmic reticulum. So microsomes omega oxidation is happening. It involves the hydroxylation reaction happening on the methyl group which is lying at the farthest end from the first carbon atom. First carbon atom near opposite end methyl group what is happening? The oxidation is happening. So it involves hydroxylation reaction. Hydroxylation means attachment of OH. CH3 OH attached and then CH2OH. That is, it can get converted to corresponding alcohol. Methyl group is converted to an alcoholic group. Then it is undergoing oxidation. CH2OH then undergoes oxidation. Oxidation is carried out by a category of oxidase enzyme which is known as mixed function oxidases. I think you have studied the different types of enzymes. There are we have got different categories of enzymes like hydroxylases, oxidases, dehydrogenases, then transferases, and different types of category of enzymes. But the oxidation reaction catalyzing enzymes, again different types are there. One is oxidase enzyme. Oxidase is again mixed function oxidase. Mixed function oxidase means it is the incorporation of molecular oxygen. Oxygen is incorporated, but the difference is that out of the two oxygen atoms present in the oxygen molecule, one of the oxygen atom will be oxidizing a substrate, and the other oxygen atom will be getting added to another substrate. Our individual split so that two molecules are oxidized at a time. Two molecules different molecules oxygen attach. Anganeyulla enzymes we call as mixed function. Mixed one substrate atoms of oxygen oxidize. Clear. It is onto two different substrate. Oxygen molecule will be splitting up into two oxygen atoms, and the two oxygen atoms goes and gets added onto two different substrates. So such an enzyme is known as mixed function oxidase. So ഇവിടെ CH2OH നമുക്കുണ്ട്. CH2OH alcohol in alcohol further എന്താണ് oxidize ചെയ്ത് കഴിഞ്ഞാൽ we get COOH, right? അപ്പോൾ CH2OH we have already got one oxygen atom. So COOH ആവാൻ നമുക്ക് ഒരു oxygen കൂടി വേണ്ടു. Clear. So molecular oxygen comes and it's the CH2OH of the fatty acid. Opposite extremely കിടക്കണ ഒരു എൻഡിൽ നമുക്ക് CO minus ഉണ്ട് fatty acid ആയതുകൊണ്ട് മറ്റേ എൻഡിൽ CH3 ആയിരുന്നു. ആ methyl group is first undergoing oxidation to give alcohol CH2OH ആയിട്ട് മാറി. Then this CH2OH undergoes oxidation by mixed function oxidase known as cytochrome P450 or molecular oxide NADPH. Right? മൂന്ന് components use ചെയ്തിട്ട് mixed function oxidase catalyze the attachment of only one oxygen atom onto this CH2OH, so that CH2OH is converted into COOH. Now what happens to the fatty acid? Now this fatty acid is having two carboxyl ends. That is we call it as a dicarboxylic acid. അങ്ങനെയുള്ള ഒരു molecule we call it as dicarboxylic acid. Clear? So now the beta oxidation can start from both sides. രണ്ട് സൈഡിൽ നിന്നും എന്ത് ചെയ്യാൻ പറ്റും? Beta oxidation can occur. Clear? For രണ്ടറ്റത്തും എന്താ ഉള്ളത്? The two ends are flanked by, or the carbon skeleton is flanked with two carboxyl ends, two carboxyl groups at both ends, so that the beta oxidation can happen from both sides at a time. അങ്ങനെയുള്ള reaction ആണ് we call it oxidation, and we call it as omega oxidation. See. This is our fatty acid, which is having the CH3 group at one end and COOH on the other end. Fatty acid is converted into what? The CH2OH. CH3 is now first alpha hydroxylase. Sorry, it's not alpha hydroxylation reaction happens. Hydroxylation reaction is carried out, so that CH3 is converted into CH2OH, right? The CH2OH. Upper H poi, right? Half O2 ആണ് വരുന്നത് because the enzyme is mixed function oxidase. So the mixed function oxidase catalyzes the incorporation of one oxygen atom to this, so that CH2OH is formed. Now this CH2OH, it is again oxidized by alcohol dehydrogenase. Alcohol dehydrogenase എപ്പോ വന്നാലും അവിടെ it is carried out by oxidation is carried out by NAD. So NAD plus H plus ആയിട്ട് മാറി ഈ ഹൈഡ്രജനും ഒരു ഹൈഡ്രജനും രണ്ട് ഹൈഡ്രജൻ ആറ്റത്തിൽ പോയിട്ട് CHO aldehyde ആയിട്ട് മാറി. Aldehyde now gets converted into acid, carboxylic acid. Again one more molecule, aldehyde dehydrogenase. So two molecules of NADH is formed, so that now the fatty acid is converted into a dicarboxylic acid. Now this dicarboxylic acid can be subjected to beta oxidation from both sides. ഇവിടുന്ന് beta oxidation നടത്താം, ഇവിടുന്ന് beta oxidation നടത്താം. Clear? Resulting in the formation of acetyl-CoA molecules. Acetyl-CoA molecules and also nadukku succinyl-CoA ഉണ്ടാവും, right? ഇടയിൽ ഒരു succinyl-CoA moleculeum ഉണ്ടാവും. ബാക്കിയൊക്കെ what we call it as short chain fatty acids known as adipic acid. Then that is adipic acid, C6 fatty acid, which is known as adipic acid, and suberic acid, C8 fatty acid, is known as suberic fatty acid. So this alpha omega dicarboxylic acid is it is EECOH. It is dicarboxylic acid, and now it's going for beta oxidation. Beta oxidation like entry both are to be first converted into the thioester form. COA right? Then the beta oxidation will be started, and the beta oxidation ends up with the formation of C6 and C8. C6 അല്ലെങ്കിൽ C8 fatty acid ആയിട്ട് മാറും. C6 fatty acid is known as adipic acid, and C8 fatty acid is known as suberic acid, SUBERIC, suberic acid, which are then eliminated in urine, right? And along with the acetyl-CoA, suberic acid അല്ലെങ്കിൽ adipic acid again undergoes complete oxidation to give rise to acetyl-CoA and also succinyl-CoA. Succinyl-CoA is entering into TCA cycle. Clear? So this is how one molecule of succinyl-CoA and remaining molecules of acetyl-CoA. അപ്പോൾ ഒരു എൻഡ് succinyl-CoA ആയിട്ട് മാറും, ഒരു എൻഡ് succinyl-CoA ആയിട്ട് മാറും, മറ്റേ എൻഡിലുള്ള എല്ലാം break down ചെയ്ത് we get acetyl-CoA molecules. Clear? So this is how the omega oxidation happens. So omega oxidation gives importance to the omega position. Up in the downstream, fatty acid will be converted into a dicarboxylic acid. Up in dicarboxylic acid, what the mixed function oxidase first come. Alcohol is oxidized to aldehyde. Aldehyde is oxidized to acid. So mixed function oxidase come. അപ്പോൾ ഇവിടെ എന്താ ഉണ്ടാവണ വെച്ച് കഴിഞ്ഞാൽ ഇവിടെ ഒരു ഓക്സിജനെ ഇതിലേക്ക് ഇൻകോർപ്പറേറ്റ് ചെയ്യും. മറ്റേ ഓക്സിജൻ രണ്ട് ഓക്സിജൻ ഐറ്റംസ് ഉണ്ടാവുന്നുണ്ടല്ലോ, രണ്ട് ഓക്സിജൻ ഐറ്റംസ് ആണ് ഉണ്ടാവുന്നത്. അപ്പൊ CH3 is converted into CH2OH. മൂന്നാമത്തെ H ഇതിലേക്ക് അറ്റാച്ച് ചെയ്തു. Right, the remaining oxygen atom is converted into NADPH plus H plus. It is happening in presence of NADP. So the in presence of cytochrome P450. It's a mitochondrial enzyme, right? So cytochrome microsomal, it's not mitochondrial, sorry, microsomal cytochrome P450 incorporates one molecule of oxygen and NADPH comes. Every mixed function oxidase നടക്കുകയാണെങ്കിലും അവിടെ NADPH reductive biosynthesis ആണ് അവിടെ നടക്കുന്നത്. So NADPH plus H plus monooxidase, it's also known as omega hydroxylase enzyme. Omega position ലാണ് hydroxylation. So it's known as omega hydroxylase. The mixed function oxidase is known as omega hydroxylase. So omega hydroxylase comes, hydroxylate the omega carbon atom to alcohol, and this is again further converted into the corresponding alcohol by alcohol dehydrogenase, right, resulting in the formation of aldehyde, right, aldehyde. This aldehyde is now converted into acid by aldehyde dehydrogenase. So in each reaction, NADH plus H plus will be obtained. Clear? So this is how the reaction is happening. Clear? So mixed function oxidases are those oxidases or those enzymes which carries out oxidation in a mixed pattern, so that only one oxygen atom will be attached to each substrate. Right, here we are having only one substrate, fatty acid. So one oxygen atom comes and the methyl group is oxidized to alcohol. Right, so that is omega oxidation. Now, what is the significance of omega oxidation? If the omega oxidation is happening whenever the beta oxidation is found to be defective. എവിടെയെങ്കിലും ഡിഫക്റ്റ് എന്തെങ്കിലും സ്റ്റാർട്ടിംഗ് ട്രബിൾ വരുമ്പോഴാണ് what happens, omega oxidation initiates. Clear? But it's particularly seen in omega oxidation main ആയിട്ട് കാണാൻ case of diabetic patients, chronic diabetes ഉള്ളവർക്ക് ആണ് കൂടുതലായിട്ട് we are having the chronic diabetes ഉള്ളവർക്കാണ് omega oxidation കൂടുതൽ. അപ്പൊ അവരുടെ യൂറിനിൽ we can see adipic acid, subearic acid, etc. Clear? Because the omega mobilization, fatty acid adipose tissue in mobilization കൂടുതലായിട്ട് കാണാം. ബീറ്റ ഓക്സിഡേഷൻ നടക്കുന്നുണ്ടാവും, പക്ഷെ ബീറ്റ ഓക്സിഡേഷൻ cannot meet the increased levels of TG breakdown. അപ്പൊ അങ്ങനെ വരുന്ന സമയത്ത് ബീറ്റ ഓക്സിഡേഷൻ കുറേശ്ശെ ഡിഫക്റ്റീവ് ആവാൻ തുടങ്ങും, കുറേശ്ശെ എൻസൈംസ് അവിടെ sluggish ആവാൻ തുടങ്ങും. അപ്പൊ അതിനെ കോമ്പൻസേറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ടാണ് what omega oxidation is taking place. Clear? So that is how the omega oxidation is happening. Significance of omega oxidation: it is an microsomal process where the omega oxidation represents a minor pathway, and it's happening mainly in diabetes. It's not a normal process. It's seen in diabetes, chronic alcohol consumption, and during starvation. Starvation ഒക്കെ വരുമ്പോൾ എന്താ ഗ്ലൂക്കോസ് ഇല്ല, അതുപോലെ ഡയബറ്റീസിലാണെങ്കിലും ഗ്ലൂക്കോസ് ഉണ്ടെങ്കിലും അതിനെ യൂട്ടിലൈസ് ചെയ്യാൻ പറ്റില്ല. അപ്പൊ ഇൻക്രീസ്ഡ് അമൗണ്ട്സ് ഓഫ് TG ഉണ്ടാവും. അപ്പൊ ആ TG ഒരുപാട് ബ്രേക്ക് ഡൗൺ ചെയ്യും. കൂടുതൽ ബ്രേക്ക് ഡൗൺ ചെയ്യുമ്പോൾ ബീറ്റ ഓക്സിഡേഷന്റെ ബീറ്റ ഓക്സിഡേഷൻ ഇസ് ഹാപ്പനിങ് ഇൻ ഇൻക്രീസ്ഡ് മാനർ. അപ്പൊ കൂടുതൽ TG വരുമ്പോൾ എന്താ ഉണ്ടാവുക, കുറേശ്ശെ ബീറ്റ ഓക്സിഡേറ്റീവ് എൻസൈംസ് സ്ലഗ്ഗിഷ് ആവാൻ തുടങ്ങും, സ്ലോസ് ഡൗൺ. അപ്പൊ അതിനെ കോമ്പൻസേറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ടാണ് what is happening, omega oxidation. So it can provide an effective means for the elimination of toxic level of free fatty acid. Free fatty acids വന്ന് accumulate ചെയ്യാതെ ബോഡീനെ പ്രൊട്ടക്ട് ചെയ്യാൻ വേണ്ടിയിട്ടാണ് omega oxidation is happening. So that is all about the oxidative pathways of fatty acid oxidation. We have started with beta oxidation, continued with peroxisomal oxidation, alpha oxidation, and finally omega oxidation. Now we are having oxidation of unsaturated fatty acids. That is, ഇത്രയും നേരം നമ്മൾ പറഞ്ഞത് saturated fatty acids, that is those fatty acids do not have any double bonds in their carbon skeleton. Carbon skeletonilൊന്നും ഒരു double bond ഇല്ലാത്ത fatty acids ന്റെ കണ്ടത് എവിടെയും ഇല്ല, double bonds are not present. All of them are saturated fatty acids. പക്ഷേ oxidation of unsaturated fatty acids is having slight difference. Again, ഫുഡിൽ എപ്പോഴും unsaturated fatty acid include ചെയ്യണം, because they are healthy for the body. എപ്പോഴും ഫ്രീ റാഡിക്കൽസിനൊക്കെ സ്കാവൻ ചെയ്ത് ബോഡിയിൽ നിന്ന് ആന്റി ഓക്സിഡന്റ് ആക്ഷൻ ഒക്കെ ഉള്ളത് പ്യൂഫെക് ആണ്, പോളി അൺസാച്ചുറേറ്റഡ് ഫാറ്റി ആസിഡ്സ് ആണ്. അപ്പൊ ഈ അൺസാച്ചുറേറ്റഡ് ഫാറ്റി ആസിഡ്, ഹൗ ആർ ദേ ബീങ് മെറ്റബിളൈസ്ഡ് ബൈ ദ ബോഡി? How are they catabolized in the body? How are they oxidized in the body? So oxidation of unsaturated fatty acids. Again, unsaturated fatty acids are of two types: monounsaturated fatty acids and polyunsaturated fatty acids. So how are they getting metabolized by the body, catabolized by the body? That we are going to discuss, but after a short break. Okay. Now classes will be resumed after the election. Okay. Hope you understood. If you have got any doubt, please do ask me. Okay. Thank you.